will have on the test. And they have told us that the last problem will not allow a calculator, and you'll have to solve or simplify expressions using functions learned in Unit 2 and 3. So these are the types you're going to see. Trig, inverse trig, logs, exponentials. All right, that stuff is what's going to be in the fourth question. Parts A and B are considered to be easy or medium difficulty. Part C should be the hardest part on this. You will have two of those that ask you to solve equations. One will ask you to simplify for that. So there's several things you need to know, and he has made a list of them for us here. You got to know log properties, exponent properties, trig identities, and unit circle. You also have to know how to convert from log to exponential, and you have to recognize inverse sign and arc sign are the same notation because they might use either one on there, which we have seen presented both ways, so they may do that as well. Logs and exponentials, it's been a while since we did those. So it might be something we need to spend a little time going over. You guys were pretty good at them when we did them, but it's easy to forget what to do. So if I've got log x plus log y, I can use the product property where I write them together and multiply those two values that we're taking the log of. If I have subtraction, it's going to become division. And if I have a coefficient right here, like this a, it can be sucked inside as an exponent for that. So those were our 3 log rules that we used. Our exponent properties, if I have 2 exponential expressions with the same base, I can put those together by adding the exponents whenever they're multiplied here. If I have division, I subtract the exponents. If I have a power to a power, I multiply the exponents. Okay, so those are important to know. And then these are all the trig identities that we had to memorize here. They don't have, like, we did do the tangents whenever cotangent and cotangents whenever tangent. He didn't put that on here, probably because it's kind of redundant if you use these right here. But this is pretty much everything you had to have on that formula sheet that we did for a quiz. And you got to have this stuff memorized, right? So your exam will be at 12. And I got to double check with Ms. Phelps on a few things about your exam. But usually what they let you do is you're supposed to come to your first period class, and then you can leave during second period and go get something to eat, and then you have to be over there by 12 for your exam. So since you're not a morning exam, you'll have a little time that morning. I definitely would not tell you to go study a whole lot and really, just, go crazy with it, because you might get yourself too worked up if you do that. But this would not be a bad thing to look over maybe in your car for 5 minutes before you go take the exam, because you got to know this and the unit circle. Wouldn't be terrible things to go look over just to make sure they're fresh in your mind whenever you're getting ready to take the exam, because these will definitely show up quite a bit on the exam, and you'll need to know them. So let's look at what the problems look like. He did not put any part C's on here, but I think he made some of his A's and B's difficult enough it kind of covers it. The part C's are going to be similar to what we're doing in A and B. They're just going to be a little harder for that, although he made these aren't simple right here. I think they're actually probably maybe slightly harder than you'll see for the actual exam. So, or at least especially part B anyway. So let's just do a few problems to try to remember what's going on here. So for part 1, it says solve g of x equals 7 for values of x in the domain of G. Now let's talk about that domain of G stuff right there. Domain of G. For our domain of G, what is our domain for a natural log function? Does it include 0? does not include 0. So 0 to positive infinity for the regular natural log, which means whatever you're taking the natural log of has to be greater than 0, right? So for this, our domain would be that whatever 3x plus 5 is has to be greater than 0. So always with natural log equations, you want to plug your answers back in and make sure you're not getting 0 or a negative in the answer. So that would be like your domain restriction. You won't do anything other than throw out an answer if it gives you a 0 or a negative inside of your natural log. I also like the way that he made this worksheet because he kind of gave you like an answer sheet area. On your actual test, you will have the question printed out for you, and then you will have an answer sheet where you actually put your work. So like, for example, what I just wrote right there would not be graded because it's not in the answer box, right? They're only going to grade what's in the answer box. So make sure that anything of importance you're writing in the answer box. So we got to do natural log of 3x plus 5 equals 7. We want to solve that for x. What should we do first? E to the power. We'll get rid of that natural log. So we need to do that on both sides. So we got 3. Actually, I don't really need the parentheses anymore. 3x plus 5 equals e to the 7th. And this is calculator inactive, so we're just going to have to leave it e to the 7th. What would I do next? Subtract that 5. So 3x is going to equal e to the 7th minus 5. And then last thing, divide by 3. And I believe that the instructions on this section tell you that you need to like combine like terms and stuff if you can, but there's not really anything else you can do with this because it's, because of that e to the 7th. So I'll just leave it like it is. That is your answer. I do need to check to make sure it's in the domain. E to the 7th is going to be a really big number. I'm going to subtract 5, but it's still going to be a really big positive number. I'm going to divide by 3. Still a positive number, right? So this number is positive. If I plug it into 3x plus 5, will I still get a positive? Yes. So no chance that is going to cause a negative inside the natural log. This is your answer. If it did give you a negative or a 0 inside the natural log, you would throw it out and say no solution. I don't think they're going to do that to you on a problem like this. They might do it to you on a problem where you get 2 answers and one of them has to be thrown out for that. Okay. Next, we got to do inverse cosine of 4x equals 2 pi over 3. The domain on this one is a little bit tricky. For inverse cosine, it is 0 to pi, but that just applies to the inverse cosine part, not necessarily your final answer. So when we plug back our answers, when we do inverse cosine, we'd only be looking from 0 to pi. We could check to make sure it works, but on most of the inverse problems I've seen, the domain does not come into play. So you don't really have to think about it as you do this. So if I want to get rid of inverse cosine, what should I use? Regular cosine, right? Cosine of inverse cosine cancels out. So we've got 4x equals cosine of 2 pi over 3. And on the actual, AP exam, you don't have a unit circle. So you got to remember everything. What I like to do is I like to sketch out a little unit circle here. Think about where 2 pi over 3 is. It's right here. What are the coordinates at that point? Negative 1/2 square root of 3 over 2. And so cosine is at your x or your y coordinate. It's x. So we're just getting 4x equals negative 1/2. What's the last thing we need to do here? Divide by 4. So x would equal, dividing fractions is easy as pie. Flip the second and multiply, and you're going to get negative 1/8. My instinct is to want to circle that answers. Did I discuss with your class circling of answers? Okay, so best I can tell, what I've seen mostly is that teachers who have graded exams before, which nobody's graded the PreCal exam, but I think it'll be similar to what the calculus exam is, usually say not to circle your answers. Because if you circle, if you do too much right here, let's say you go plug something back in or something. If you do too much and you circle your answer, the grader would ignore it if you had the right answer on the page somewhere. If you circle something and it is wrong, let's see. You've already got this paper, I think, Webb. I gave it to you yesterday. Is that right? If you circle something and it is wrong, but you had the right answer, you definitely are not going to get the point. So most of the people I see that have graded before tell their kids not to circle or box in answers. It certainly is not against the rules. It's just if you circle something and it wasn't the right answer and you had the right answer there, you might lose points. I'm grading the calculus exams this time, which I've never done before, so I'm going to try to pay close attention to see if kids are losing points for that or if it really doesn't matter one way or the other. I like circling my answers because it makes it clear what my answer is, but I see why some teachers say not to on this test. So do with that what you will. I'm not going to stress to you that you got to do it one way or the other, but your work does have to be neat, because if you just have random stuff everywhere, they may not give you an answer. I think you would be fine with what I've done here, though. They would read that as negative 1/8 being your answer. All right, let's go to B. B is going to be your rewriting section. So this is a trig rewriting. This we have just done, right? It should be relatively fresh in our mind. So j of x equals secant x cotangent squared x. All right, what would you guys try first? That's what I would do. I do 1 over cosine x times cosine squared x over sine squared x. And this is multiplied together. I don't have any plus or minus signs. Can I cancel anything? One of the cosines can cancel. So this cosine can cancel with one of my cosines here, which is going to give me cosine x over sine squared x. And the question asked me to leave everything as a cosine. So what does my last step need to be here? 1 minus cosine squared x in that bottom. So cosine x over 1 minus cosine squared x. And the directions say you'll have a fraction, we do, that's good, involving powers of cosine. So I've got a power here, not on top, and no other trig function. So what we have meets their requirements, so we'd be done. They say don't circle, is what most of the teachers I hear talking about this say. And I've been to some trainings for that. So they say don't circle. Your work needs to be neat so that pretty clearly here whatever's last is your answer. If you're and you need air, if you do run out of room and have to go over somewhere else, draw an arrow so the grader's following what you're doing. Because if it's not in line, either across or down, they may not think you're connecting this piece to this piece. So, all right. I think the last part of this one is kind of difficult. here, I mean, it's not that bad, but it is on the more difficult side. So we got 9 to the 2x plus 3 times 3 to the x plus 2 over the square root of 3. And they are telling us to rewrite this in the form of 3 times ax plus b, where a and b are constants. So that must mean everything can have like a base of 3. Although, currently, this does not have a base of 3, and this doesn't have an exponent. It's got a 3, but not the exponent. So we're definitely going to have to rewrite those pieces. 9, how could we rewrite it so we would have a base of 3? 3 squared. So it'll look like this. We'll have 3 squared to the 2x plus 3. We're going to leave this alone, 3 to the x plus 2. And then let's talk about the bottom. How could I write that as an exponent? I need it to be 3 to something. 3 to the 1/2 power, because we may have forgotten this, but if I have like x to the a power underneath the b root, that is x to the a over b. So that's like a side note. You wouldn't put that on your page, and other than just as a reminder. But we can write that as 3 to the 1/2. So now we need to keep combining though, because I need to have just a single 3 raised to a power. So when I have a power raised to a power, the square raised to a 2x plus 3, what can I do with those exponents? Multiply. So it's like that 2 gets distributed. So that's going to give you 3 to the 4x plus 6 times 3 to the x plus 2 over 3 to the 1/2. All right, what do I do with exponents when I multiply them together? I add those together. So I've got 3 to the 5x plus 8 over 3 to the 1/2. And what do I do when I divide? Subtract. So that's going to be 3 to the 5x plus 8 minus 1/2, which is going to be 3 to the 5x plus 7.5. And now you have a 3 raised to a power. It's ax plus b. So you are done. Okay, questions there? All right, let's try the second one here. All right, so this one has got some log stuff. I searched my Facebook group for this. I don't know why. I mean, I was thinking for sure there was a discussion on why they put the 10 on all the logs. But everything I have seen from Mr. Passwater and from AP, if they have a log that has a base of 10, they're writing the 10. I don't know if that's because maybe there are some countries or textbooks that don't just use a regular log for that. But best I can tell, they don't use like the common log with no base at all. For log base 10, they are putting a 10 every time. So I think you'll still be okay if like you don't write it, if you just write log of 3x plus 1 or 3x minus 1. But to be on the safe side, I would just use the base of 10 right there. But this first one has base 2, obviously. So this one, for A, we're supposed to rewrite a form of log base 2 of some expression. So we're combining these together. What would you guys do first on that? If we're trying to put this all together as one log. Yes. You want to make the coefficients an exponent, and you actually can do the same thing with the 1/2 right there as well. So we would start off, and g of x would equal log base 2 of x cubed minus log base 2 of x plus 1 to the 1/2 power minus log base 2 of 5. Now that we don't have any coefficients, we can start using either our product or quotient rules. I would do the first two and then worry about the next one, just for clarity here. So, or there's some other options. There's other ways you can deal with this, but I'd probably just do the first two and then worry about the last. So when we have subtraction, we put those together using what operation? Division. So we're going to do log base 2 of x to the third over x plus 1 to the 1/2 minus log base 2 of 5 and then we're going to do division again. So we'll have log base 2 of x to the third over x plus 1 to the 1/2 divided by 5. And let me look real quick. I'll put that right back up. Actually, let me freeze it while I'm looking for this. Let's do that. Look this up real quick. Out of tissues back there and get some. Let's see. Response question. Yeah, on your number 4, it will have a box right here that says about your domains here. Solutions to equations must be real numbers. Determine the exact value of an expression that can be obtained without a calculator. For example, log base 2 of 8 can be evaluated. Cosine of pi over 2. You have to figure those things out. Here it says, unless otherwise specified, combine terms using algebraic methods and rules for exponents and logarithms where applicable. So, for example, if you have 2x plus 3x, you can't leave it 2x plus 3x. You got to make it 5x. If you have 5 squared times 5 to the third, you can't leave it that way. You got to make it 5 to the fifth. This would be x to the third. Natural log of 3 plus natural log of 5 should be natural log of 15. You should combine anything when you can. What they don't say is that you can't leave complex fractions. So maybe we could be done here. But I am worried that having to combine things that should be combined is going to include you should not leave complex fractions for that. Yes. Oh, sorry. So I'm afraid, let me flip back over there since it was frozen. This box will look the same every time on 4. And so here's where I'm talking about right here. You got to combine like terms for that. So it doesn't say anything specifically about complex fractions. That is generally not a good mathematical practice to leave complex fractions. So I think that you need to go ahead and flip and multiply here. So if you put that over 1, you will get log base 2 of x to the third over x plus 1 to the 1/2 times 1/5. And I think I would write that like this, log base 2 of x to the third over 5 times x plus 1 to the 1/2. I think that's going to be the best way to leave the answer. Everybody all right there? All right. 2 is a trig one, so this is what we've been doing recently. You're supposed to rewrite only using cosine. And again, I think that you can't leave complex fractions for this, because when I have h of x equals 1 minus sine squared x over secant x, I can turn this into just cosine right away, right? Because what is 1 minus sine squared x? Cosine squared x. What is secant x? 1 over cosine x. I don't think we can, even though it's all cosine now, I don't think we can leave it like this, because you have stuff that could be combined. So you need to flip and multiply. You'll get cosine squared x times cosine x over 1. What's that going to give us for our answer? Cosine cubed x. Okay, any questions there? All right, part B is going to ask us to solve equations. So for number 1 of part B, we'll do log base 10 of 3x minus 1 minus log base 10 of 3 equals 2. What do I need to do first there? Okay, combine them and use division. So we'll have log base 10 of 3x minus 1 over 3 equals 2. Now we're trying to get to that x. We're trying to solve for x. So what would I do? 10 to the power. And that's going to give me 3x minus 1 over 3 equals 100. Now we're down to just a simple equation. I'm going to multiply both sides by 3. 3x minus 1 equals 300. I'm going to add the 1. 3x equals 301. Divide by 3. X equals, that won't reduce or divide evenly, so just leave it 301 over 3. And we have to have positives when we plug it back in, so we do want to check for that. This is a fairly big number. Actually, when we multiply it by 3, we'll get 301 minus 1. That's 300. It's positive, so that is okay for our answer. Okay, questions? All right, and the last one, we're going to have 2 sine x cosine x plus sine x equals 0. What should I do here? Okay. What then? Because what you have suggested is a valid move. What can we do with it after that, though? Sine 2x is not sine squared x, so no. So you can't pull out just a sine. It has to be of something. So this, although it works, it's a dead end. So you don't want to do that. And if you do this on your exam and you realize it's going nowhere, mark it out. Don't erase it. Go show you're doing your work somewhere else, right? So, but factoring out a sine is a good idea, but we don't really want to like change it here. Both of these have a sine, so we could just factor a sine out here. Sine x times 2 cosine x plus 1 would equal 0. All right, If I multiplied that back, sine x times 2 cosine x would give me 2 sine x cosine x. Sine x times 1 would give me that sine x there. So it's factored correctly. What do I do after I factor? Set each one equal to 0. So I got sine x equals 0. Where does sine x equal 0? 0 and pi. And this problem asks us to give answers only between 0 and pi, but it's got brackets, so it includes 0 and pi. So we're going to put both of those answers. The other part over here is going to be 2 cosine x plus 1 equals 0. That's going to give us cosine x equals negative 1/2 once we solve it. I'm shortcutting a little work there. Where does cosine equal negative 1/2? At 2 pi over 3. And it would also be 4 pi over 3, but should I include it? No, because they told me to only go from 0 to pi. So I would just stop here. Those would be my 3 answers. I have a hard time on this one not circling the answers, especially because they're like not all together. But you could do like x equals 0, x equals pi, x equals 2 pi over 3, if that makes you feel better to have those listed there. Or you can circle them. If you feel like your work is messy and the grader's not going to be able to tell what you mean as the answer, just circle your answers. It's probably better than having to really try not to have messy work in the first place. That would be your ideal. Okay, questions on those?